Here are your notes for 1.3. This is 1.3. It's solving or simplifying algebraic expressions. All right. So what we're going to do is we're going to look at expressions and we're going to talk about the parts and everything. So first off, we're talk about what an expression is. This is an example of an expression: 18x squared minus 13y plus 2 minus 2x squared. All right. Notice this expression doesn't have an equal sign in it, and that's what makes it an expression and not an equation. All right. Your terms, if we look at this, the terms again are separated by signs, is what as how you can figure out what the term is. So whenever you come to a sign, that starts a new term. So our first term is 18x squared. Our next term will be a negative 13y, because again, whatever sign's in front of it stays with that term. All right? And then a positive 2. And then a negative 2x squared. All right? So those are our terms. All right? The next thing we're going to talk about is like terms. All right? Like terms are when they have exactly the same variable raised to exactly the same power, or if they're both constant terms. All right? So like terms in this one are 18x squared and the negative 2x squared are an example of like terms. All right, our coefficients. All right, coefficients are the numbers that are beside the variables. All right, so in our 18x squared, the coefficient would be 18. In our negative 13y, the coefficient would be a negative 13. 2, that doesn't have a coefficient because it doesn't have a variable. And then negative 2x squared, the coefficient is negative 2. All right. Constant terms. Constant terms are the terms that don't have any variables. So our only constant term would be our positive 2. So 2 would be a constant term. All right, and that's our terms, like terms, coefficients, and constants. You should know what all of those are. All right. Next part, we're going to identify the parts of the expression. All right, this is example 1, so we're going to identify the number of terms, the coefficients, and the like terms. Okay? So the first thing is number of terms. We have 1, 2, 3. So there are 3 terms. And again, those terms are 12, negative 8y, and negative 3y squared. All right, our coefficients, all right, our coefficients would be negative 8 and negative 3. All right. Like terms, we do not have any like terms in this expression. There's no like terms. All right. All right. The next one. All right. Identify the number of terms. We have 1, 2, 3, 4, 5, 6 terms. I'm not going to write them all out, but we have 6 terms. Our coefficients are, in front of this x squared, it's considered to be a 1, so it would be a 1, negative 8, 4 doesn't have one, negative 12, negative 3 doesn't have a coefficient, that is just a constant term, and then positive 5. All right, so those are our coefficients, and then our like terms. In this one we have x squared and negative 12x squared. So x squared and negative 12x squared. And we also have positive 4 and negative 3. All right, so those are all the like terms. All right. So I'm expecting you to be able to do that now. Identify the number of terms, coefficient, and like terms in each expression. All right, next we got to talk about expressions. An expression is simplified if there are no grouping signs or grouping symbols and no like terms. All right, so that's how you can tell it's simplified. You don't have any grouping symbols, which means the parentheses. All right, and you don't have any like terms. All right, so that's how you can tell if it is simplified. All right, two algebraic expressions are equivalent if they simplify to exactly the same thing or the same expression. All right, so yeah, two expressions are equivalent if they simplify and they're exactly the same. All right, so now let's talk about simplifying. All right, one way we can simplify an expression is we can simplify it by combining like terms. All right, so our 7x and a positive 4x, again, you follow the rule for addition with them, and remember the sign stays in front. So we got a positive 7, a positive 4. That gives us an 11x, and that's simplified. Okay? Next, B, we have 3x squared minus 4x minus x squared plus 9x. Like terms, we have a 3x squared, and we have a negative 1x squared. So again, the rule for addition says that if the signs are different, you subtract, so 3 minus 1 gives us 2, and you take the sign of the bigger number. So 3 is bigger, it's positive, so it would be a positive 2x squared. All right? And then we have another set of like terms. We have a negative 4x and a positive 9. Again, signs are different, so the rule says we subtract. 9 minus 4 is 5, so we get 5. Take the sign of the bigger number. 9 is bigger, it's positive, so it's plus, and it's going to be the x. All right, so that simplifies to 2x squared plus 5x. All right, and then in C, we have, let's start with our x's. We have a negative 8x and a positive 4x. Again, signs are different, so we subtract. 8 minus 4 is 4. Take the sign of the bigger number. The 8 is negative, so it's going to be a negative 4x. All right, and then we have a 6y and a negative 9y. Again, this is positive, this is negative, so signs are different, so we subtract. 9 minus 6 is 3. Take the sign of the bigger number, which is negative, so it's going to be a negative 3y. All right, and that's how you simplify them, by combining like terms. All right, another way we can simplify them, or that you would simplify, is to get rid of these grouping symbols, the parentheses. All right, so to get rid of them, we would have to distribute. Now, be very careful when you're distributing. You have to distribute the number in front, but you got to also distribute the sign. So we would drop our 18 down. Don't do anything with that. But now we're going to take our negative 4 and we're going to distribute it. So we would do negative 4 times x gives us negative 4x. And then we would do negative 4 times negative 2. Negative times negative is positive. 4 times 2 is 8. All right? And now we're not done because we haven't finished simplifying, because now we still have like terms. We have an 18 and an 8. All right, so I'll drop down my negative 4x. And then I'll combine these. The signs are the same, so I add them and get positive 26. So I get negative 4x plus 26. All right, and now in B, again, we're going to distribute. So I'm distributing a positive 3 this time. So 3 times the 4, I get 12. And then 3 times the negative x, I get negative 3x. Here I'm going to distribute my positive 2. 2 times x gives me positive 2x. And then 2, positive 2 times negative 7. Positive times negative is negative. 2 times 7 is 14. All right, so I did my distributive property. Now I'm going to combine my like terms, start with my variables. So I got a negative 3x and a positive 2x. Gives me a negative 1x. And then I got a positive 12 and a negative 14, which gives me a negative 2. All right. All right, so next we have a checkpoint. I'm going to stop the film right now, it's video right now, and you're going to do that checkpoint. All right, so here are your answers. We got a positive 7x and a negative 3x, gives us a positive 4x. This one we have a positive 1x and a positive 10x, that gives us 11x. And then we have a positive 1 and a negative 8, which gives us a negative 7. And then this one, we have a positive x squared, 1x squared, and a negative 4x squared, which gives us a negative 3x squared. And then we have a positive 1x and a negative 5x, which gives us a negative 4x. All right, the next one, we keep our 3. We distribute our positive 2. Positive 2 times x gives us positive 2x. Positive 2 times 4 gives us positive 8. Keep our 2x. Combine our positive 3 and our positive 8, and we get 11. So we get our answer, 2x plus 11. All right, next one, 5. We have to bring our x down, distribute a negative 6. So negative 6 times x gives us negative 6x. Negative 6 times a negative 2. Negative times negative is positive. 6 times 2 is 12. Combine our like terms. We got a positive 1x and a negative 6x. Gives us a negative 5x. And that's it. All right, and then our last one, we have a 3. We have to distribute that. 3 times x gives us 3x. 3 times negative 1 gives us a negative 3. Now this one, notice we don't have any number out here, but we have a negative sign. So you can put a 1 if you want to, and then distribute that as a negative 1. All right, so a negative times a positive gives us a negative, so it's a negative 1x or negative x. And then a negative 1 times a negative 9 gives us a positive 9. And then we combine our like terms. 3x and negative 1x gives us 2x. And then we got a negative 3 and a positive 9, which gives us a positive 6. And that is our answer. All right, so that was your checkpoint. All right, and example 4. Example 4. You got a rental car company charges customers $52 for the first day plus $48 a day for each additional day. All right, so the first thing we have to do is write and simplify an expression that gives us a total cost. Okay. All right, so it's going to cost us 52, so we have to put that down. All right, plus it's going to cost us 48 for each additional day. So we have to take the number of days and minus 1, because that minus 1, we already paid for the first day. All right, so we don't have to pay for that again. So that's what our expression would look like, is 52 plus 48x times x minus 1. Now it says to write and simplify it, so we have to simplify this now. So we would do 52, 48x minus 48. All right, and then combine our like terms. We got a 48x, we bring that down. And then we got a positive 52 and a negative 48, which gives us a positive 4. All right, so 48x plus 4. All right, that would be our simplified expression for this one. And then it says find the total cost for renting a car for 6 days. All right, so that gives us 48 times 6 plus 4. All right, so we do that real quick. Let's see, 48 times 6. 6 times 8 is 48. 4 times 6 is 24 plus 4 gives us 28. So that gives us 288 plus 4, which gives us 292. So it's going to cost us $292 to rent it for 6 days. All right, and then you have a checkpoint. All right, so I can pause the video, and you can do the checkpoint, and then I'll start the video. Right, calling card charges $1 for all phone calls up to 15 minutes and 25 cents for each additional minute that's after the 15 minutes. So again, write and simplify an expression, it gives you the total cost. So it's going to be $1 plus 25 cents for each additional minute over 15. So we got to subtract that 15. So x minus 15. All right, and then we want to simplify that. So we got 1 plus 0.25x minus 4 0.25. No, hold it. 4 into that is 3.75. 3.75. All right, so then we gotta combine our like terms, so we get 0.25x minus 2.75. No, that's not gonna work. That's not gonna work. Well, it'll work, but it'll only work, well, it'll work 0.25x minus 2.75. This equation will work, it has to be at least 15 that you put in there, all right? So it has to be at least 15 that you would put in there, all right? So then it says, use your expression number 1 to find phone calls that last for 28 minutes. So we would do 0.25 times 28 minus 2.75. 0.25 times 28 gives us 7. So 7 minus 2.75, which would be 4.25. All right, so it costs $4.25 for a phone call that lasts 28 minutes. All right, and then use the expression for number 1 to find the cost of a phone call that lasts for 1 hour and 10 minutes. Now, this hour, you got to change that into minutes. So that would be 60 minutes plus the 10 minutes. So that would give us 70 minutes. All right, so again, we're going to do 0.25 times 70 minus 2.75. All right, let's see. 4 goes into 70. 1, 30, 7 is 28, and 2, so 17.5. So this would be 17.5 minus 2.75. All right, and let's see, that would give us $14.75. All right, $14.75 is how much it will cost. All right.